I'll stand over here. Right, absolutely brilliant coming from these new guys. First time they've been up in front of a live audience, so to speak. Absolutely fantastic that. It's good to see. I believe it's been recorded and subtitles being added later, and apologies for my northern accent, but there might be some translators in the room that can work it out. My name's Mick Greensmith. I work for a company called Power Efficient Systems, and we manufacture a number of technologies that basically you put in and it saves energy without you actually having to do anything else, which is fantastic, because one of the most difficult things out there is to change people's habits. And there's lots of intelligent equipment and smart equipment you can do to reduce energy. If we could all change our habits, that would be even better in solving the problem. So what is voltage management, and why do we need it? So what it is it controls and stabilises the voltage coming into the building. Electrical energy is something that we're all using. Everybody uses it. And it's actually, we're using more and more of it all the time, and we're relying on less on different types of energy, and we will have to rely even less on the energy such as gas and oil in the future. You'll reduce the energy being used in a building by reducing the voltage coming in. It maintains the security of the supply. It actually makes this electrical infrastructure safer and more stable. And we look at targeting the optimum level of voltage for a building, because all equipment has different voltages that it wants to work at most frequently, or most efficiently, sorry. But there is sort of like a sweet point for the building, so we look at getting the sweet point for the building. It was introduced as a power quality measure, but it's now been used as an energy saving measure, because that's the actual added benefit from it. And it extends the life of all electrical equipment, so it reduces your maintenance costs, and it acts like a control valve coming into the building. So why do we need it? 1994 EU legislation came in place. You'll see on any piece of electrical equipment now there's a little mark that says CE, and that means it conforms to European standard. That means that it will work anywhere between 207 and 253 volts. And the sweet spot is somewhere between 220, 225, single phase to neutral, because we have single and three phase voltages. The average voltage in the UK is 242 and rising. Actually, the average voltage on mainland Europe is between 220 and 230. And ours is sort of between 240 and 250. So we're delivering 20 volts more than all the electrical equipment needs. And it means that all our appliances are operating higher and closer to the red line effectively. That means it results in damage to the equipment overheating. Generally speaking, that over voltage is turned into heat and noise and electrical vibration, which generally speaking is not beneficial to the electrical appliances. So just looking at this voltage scale, that's where we are, the nominal voltage here in the UK, around about the 242 mark. That's the maximum that legally there is allowed to be delivered to you. And down here is what the nominal voltage is supposed to be, 230 volts plus or minus 10%. And down here is where most equipment runs most efficiently. So you can see that actually where we are in the UK, we're further away from the middle than we would be if we were down at the bottom with the rest of Europe. So just to put the technical bit to rest, because we sometimes get asked about Ohm's law, this just makes it really simple. A 2 kilowatt appliance is rated at 2 kilowatts at 230 volts. So at 242 volts, it runs at 2,240 watts. And that same 2 kilowatt appliance at 222 volts, with a 20 volt reduction, runs at 1,881 watts. That gives a saving on watts, and it's kilowatts per hour that we pay our electricity bills in, of 16%. So just to reiterate about the pressure side of things, voltage is very much, there's a lot of expressions in electrical circuitry similar to water, and voltage is sort of the pressure in the pipe. And the higher the pressure, the more likely things are to burst. It really is as simple as that. You get words like current and flow, and because electricity behaves very similar to water, although it's not a really good idea to mix the two. The different types of voltage control that we manufacture, and again this depends on the type of building and operation, is we have a fixed tap multi, which is a fixed multi-tap compact unit, which we tend to do up to around about 160 amps. That's if you've got an electricity consumption of 350,000 kilowatt hours-ish, up to that. This is the kind of product that we will put in there. Then we have variable, so when you're over that load, so you're over that 350, 400,000 kilowatt hours, manufacturing processes where things change throughout the day, then we put a stabilised range in. And then for 24-hour operations where voltages vary massively, both up and down, we will do a fully stabilised unit. All of these products would only be done following a full site survey. So when we come and do a survey, we look at the kilowatt demand or the kVA demand. We size our equipment to the size of the operation. You can have buildings that have 1,000 amp incomers but only pull 200 amps, and you might think, oh, I've got to put a 1,000 amp unit in there to match the incomer. What we do is, because our units all come with their own circuit protection built in, we'll match the demand of the building. So we build into it sort of a bit of a headroom, around about 25 to 30% headroom on a unit, to allow for any planned expansion or unplanned expansion, plus anything else that might crop up. We look at the power factor. Power factor is a massive issue within manufacturing operations. And we look at the voltage, obviously, because we want to determine how we're going to set things up. We look if there is planned expansion. We look at other energy saving measures like non-linear loads, where maybe VSDs or inverters have been put in as an energy saving measure, because they have an effect on the amount of savings or reduction that voltage management can have. And we look at the load dynamics. We look at when the equipment's coming on, how long it's running for, what type of equipment it is, can it be switched as well. And from that we then design the unit bearing in mind voltage fluctuation, the current that's been used, the size of supply and the total kilowatt hours. Just in closing on that, just want to say that this technology is not new, isn't voltage management. As a company, we're a UK manufacturer. We've been in business for 15 years making this equipment. The actual technology has been around for over 100 years. It's very, very reliable and has no serviceable parts other than the normal electrical inspection. So if anyone wants to find out a little bit more, get back in touch with Energy Renewals and we can do your free site survey based on that. So I'll pass you back.